Quadratic functions, finding the vertex, the axis of symmetry, and the intercepts. The X-Intercepts, if we have any, and the Y-Intercept. So for quadratic functions, we have f of x equals ax squared plus bx plus c, where a is not 0. If a was 0, you wouldn't have x squared. It wouldn't be quadratic. The vertex is negative b over 2a, and then f of negative b over 2a. This looks a lot worse than it actually is. Negative b over 2a is just a number. It may be a fraction, it may be a decimal, it may have radical, could whatever, but it's just a number. And then once we find that number, whatever this number is, we just plug it into the function. F of 2, f of 8, f of 1/2, whatever it is. Okay? And that gives us our y value. So the x value is negative b over 2a. It's a value. We figure it out. Then we take that value and plug it into the function f to get the y value. The axis of symmetry is x equals whatever this value is. Those things are the same thing. So it's x equals that. There's another version of this, and I kind of put it in gray here. This is a little more straightforward on vertex and axis of symmetry, not so much so on the intercepts. All right. But f of x equals a times x minus h in parentheses squared plus k, where a is not 0. Again, you wouldn't have x squared. The vertex is hk. I want you to notice this is minus h. It's in parentheses. This is very common in math. When it's in parentheses, it's negative, and it's the opposite. So we take negative h and we change it to h in the vertex. But then the plus k is not in parentheses. It's just tacked on the end. You just bring k down. You don't change its sign. Okay? So a minus sign in a formula means change it. So h, you change it when you bring it out of the formula or when you put it in, and then k stays the same. It's not, doesn't have a minus in front of it. And then the axis of symmetry is x equals h. On the axis of symmetry, you must put x equals, because x equals means it's a line, it's a vertical line. All right, that is a must. You can't just say 2. It's x equals 2, or 17. It's x equals 17. Cannot just be 17 or 1/2 or 2.3 or whatever. It's got to be x equals 2.3 if that's what it is. We won't do one that's 2.3. The axis of symmetry is typically shown on the graph as a dotted line, and it's vertical for quadratic functions. All right, you can have other parabolas. That's what quadratic functions, when you graph them, are called parabolas. You can have other parabolas that are turned different ways, and so the axis of symmetry won't be vertical, but they won't be functions. They'll be a graph of a quadratic equation of some type. The vertex is a point that is always on the axis of symmetry. Look, if the x's are the same, if x equals this number is the same, then that x value's got to be there. That's got to be on the axis of symmetry. Has no other choice. Okay? So when you have your dotted line, then the vertex is here, or it's here, or it's here. And then the parabola is either going to smile, it's going to open up, or it's going to frown, it's going to open down. Okay? So how do we know if it opens up? If a is greater than 0, right? Let's go back and look. We have a. We have a. A is greater than 0. Here's a, and here's a. Okay? So if a is greater than 0, the parabola opens up. If the vertex is the lowest point on the graph, if it opens up, so we have something that looks like this. And I don't have it on a grid here. I just have the shape, the basic shape. You know, it's smiling at us. This is the lowest point, and there's the axis of symmetry right there. Okay? So what if a is less than 0? That means negative, right? This is positive. This is negative. Okay? Negative a and positive a. All right. So if a is less than 0, then the parabola opens down. I call that frowning. So you hear me say, does it smile or does it frown? Really, does it open up or down? All right. Then it opens down if it's less than 0 and it's frowning. The vertex is the highest point on the graph, right? We have the parabola, and here's the highest point. It's a maximum. Okay. This is a minimum. And you know, if you go further in math, you start talking about local, like right around that point, it's the highest point. So it's a local max or local min, relative. Sometimes the word relative is there. So that's not necessarily for this class, but just some terminology if you happen to hear it along the way somewhere. To find x-intercepts, you let y equal 0. That's how you find x-intercepts always. If you have a function that's in terms of x and y, or f of x and x, which f of x is y, then you let y equal 0. Okay? Always, or f of x equals 0. Then solve for x. Recall f of x is y, right, which leads to ax squared plus bx plus c is 0. You factor it or use a quadratic formula, or if it's in this form here, you're going to use a square root property. You're going to subtract k, divide by a, square root property, and then add h with a plus or minus, right? Because the square root property has plus or minus in it. You're going to get 2 answers there. Unless, of course, you end up with a 0 somehow and you have just one answer. So for parabolas, you will have either examples of each case below, 2 x-intercepts. So you have a parabola whose vertex is below the axis and it opens up, so it crosses twice. It's above the axis, it opens down, so it crosses twice. Okay, Either that happens, or you have one intercept where the vertex is actually on the axis, right? It just sort of bounces off the axis there, right? So it only has one x-intercept. And then if your vertex is above the x-axis and it opens up, it doesn't cross the x-axis at all. There's no intercepts. Same thing if it's below it and opens down. So you can have two x-intercepts, one x-intercept, or no x-intercepts. So we'll practice finding the x-intercepts, but when I graph parabolas myself, I don't actually try to find the x-intercepts just because they may not exist. Now, if I get stuck and I go, well, what does this thing really look like, then I may go do that, okay, if I need some extra points to graph it or whatnot. But typically, I can get the basic shape and where it's at relatively close without finding the x-intercepts. But I still need to find them because they do have merit. Like if you wanted to, if this quadratic function represented something in business and you want to know, hey, where's my break-even point? 0 maybe if it's talking about profit. Well, then I would want to be able to solve, right, and get that x-intercept. So here, to find the x-intercept, the y-intercept, you let x equal 0. It's the same way you do it with lines. It's always that way. Any intercept you ever want to find, no matter how many variables are there, you go through there and you find it with letting all the other variables be 0. This is the same thing as finding f of 0. Then you solve for y, and there is exactly one y-intercept since these are quadratic functions. My point is it's getting wider and wider and wider forever, so at some point, wherever the y-axis is, it's going to cross it. There is exactly one y-intercept for quadratic functions. You can't have more than one or less than one. It's got to be one. All right, so let's find the intercepts. Let's practice finding these things. Now, we know, look what I did. I gave you 2 points here for x-intercepts. If you only get one x-intercept, just mark through the other one or scribble through it, do something to say, hey, it's not there, okay? Or just leave it blank. This is the only time I'll let you leave something blank and be okay, but I'd rather you mark through it or say, there's not another one, or there's no x-intercepts if you don't have any, or there's only one and fill one of them in, x the other one out kind of thing. But I'm not going to give you one blank if there's only one, 2 blanks if there's 2, and no x-intercept blanks if there's not any. I'm going to give you 2 every time, and you have to figure out how many of them you fill in or not. Okay? So here, k of x, little k of x equals x squared plus 12x minus 28. All right? So if I want to find the x-intercepts, okay, or interceptor if there's even any of them, okay? So to do that, you let y equal 0, right? That's this thing equals 0. Y is the same thing as k of x. So 0 equals x squared plus 12x minus 28. So you can either factor this or use the quadratic formula. I'm going to factor it if it will. I want factors of 28 to subtract to give me 12. That's going to be x and x to start it. It's going to be 14 times 2. So I do 1 and 28, 2 and 14, or 4 and 7. And those subtract to give me 12. Factors of 28 and subtract to give me 12. If that gives you trouble, go watch my list method factoring video, all right? Because that's exactly what I did here, and it works every time. All right, then the signs are different. Bigger number gets a plus, okay? So 14 gets a plus, 2 gets a minus, and then I just set each one of these things equal to 0. And then solve each one of them. Oops. And I know some of you don't want to write all these steps down, and that's fine as long as you don't miss it, okay? So x is negative 14 or x is 2. Don't put the 2 here. That's not where that goes. It's negative 14 for x or 2 for x. Now, I found 2 of them this time, but what are the y values? Well, look, what do we let y equal? 0. For intercepts, you can always plug in 0 for the other value. It's always going to be 0 if it exists. If it doesn't exist, there won't be a 0 there because it doesn't exist, right? But if they exist, they're going to be 0 for the other variable. So negative 14, 0, 2, 0. It doesn't matter what order. 2, 0 first, negative 14, 0 second. It doesn't matter. Now, it matters that negative 14 is first in front of the 0 inside that point, but whether you put negative 14, 0 or 2, 0 first doesn't matter. All right, so now what about the y-intercept here? What about the y-intercept here? Well, find the y-intercept. That's to let x equal 0, right? So that's going to be the same thing as k of 0. That's going to be 0 squared plus 12 times 0 minus 28. So it's going to be 0 plus 0 minus 28, which is Negative 28. And that's the y value this time. And how did I find it? I let x equals 0. By the way, when it's in this form, when you're in the form ax squared plus bx plus c, right? If f of x equals that, then the y-intercept is 0c every time. Every single time it's 0, c. If it's in that form. If it's in that other form with the a and the x minus h in parentheses plus k, right, then that's not the case. You got to plug it in and figure out what it is. Plug in 0, for x and figure it out. You can't just read it. This one is just 0c every time. So let's look at another one here. X-intercepts, how do I find them? I say 0 equals x squared minus 8x plus 15. And so then I'm going to factor it. I got x, and I need the factors of 15 that add to give me 8. 3 and 5, right? Doesn't matter if you put the 3 or the 5 first, just the signs are what matters. Here, both signs are negative, right? I know these are different up here. That's not what I'm talking about. The plus 15 says they're the same. They're both, and they're both whatever's in front of the 8x, which is negative. So then we take each one of these and set them equal to 0. And then we're going to add 3 to both sides here to get 3 equals x, or x equals 3. And then over here we're going to add 5 to both sides to get 5 equals x. So then we get 3. So we get 3 and 5 as my x values, and my y values have to be what? 0. So again, I didn't have to get 2 of them. I just did here, right? I just did get 2 of them here. So you could get 1 or none. And then here for the y-intercept, we're going to find f of 0, which is 0 squared minus 8 times 0, and you already know it's 15, right? Because it's 0c. I don't know why I put 115 there, so let me fix that. So then 15 is the y value, and then what's the x value? 0. All right, so 0, 15 is the y-intercept for this one here. So now let's go find the x-intercept and the y-intercept for this one. So for the x-intercept, or x-intercepts if there's more than one, all right, we're going to let the whole thing equal 0. 3 times x minus 2 squared plus 7. Remember when it was in this form, we said we're going to use the square root property. We're going to use the square root property. So what we're going to do is I'm going to move the 7 over, subtract it from both sides, right? Undo addition, subtraction first. We're trying to get the squared by itself so we can use the square root property. We divide by 3. Right? Don't assume right now that it's negative, it's bad. Wait till you divide. You get negative 7/3 equals x minus 2 squared. So the square root property says x minus 2 equals plus or minus the square root of... Wait a minute. This is not real, right? Not real. Which means you have none. So you can scribble through them, write none. I don't have any x-intercepts, no x-intercepts, whatever. Write none there. If you're not in my class, find out what your teacher, professor, instructor wants. I really don't want you to leave it blank. I said that, but I really want you to tell me something so I know you know that they don't exist and you just didn't try. So none, ain't there, whatever, not any, no x-intercepts. Don't put zeros in there. That's actual points. Mark through it if you want. If you want to, you could mark through it. You could go, no x-intercepts. Okay? You could do that. Okay? However you want to write that, none through there, whatever, no x-intercepts. All right, so what about the y-intercept? The y-intercept. So for the y-intercept, it's not just going to be looking at it and say, oh, 0c. It's not something 7 or whatever. We're going to have to find g of 0, and we're going to go 3 times 0 minus 2 squared. I'm plugging that in. Plus 7. Right? That's what I'm plugging in for x. So this is going to be 3 times negative 2 squared plus 7, and that must be in parentheses. What do you do first? Square. What is negative 2 squared? In parentheses, it's what? 4. So 3 times 4 plus 7. What is 3 times 4? 12 plus 7. and then put 12 plus 7 together, and you get what? 19. So 19 is the y-intercept, and you got it from letting x equal 0. So 0, 19 is the y-intercept. And on this one, there are no x-intercepts, right? You got something that was not real when you did the square root property. I don't want you to think that just because it's in this form up here that there's no x-intercepts. Just that's the example I gave you here, okay? You could have tried to factor in quadratic formula and the other stuff and came out with the same thing with negative and under the radical, and you could have said, you know what, there's not any. Either way, it could work out that way. So don't just assume that, oh, well, it didn't work that way this time, so it must be it. All right, so find the vertex and the axis of symmetry for the following quadratic functions. The axis and the vertex. So again, this is ax squared plus bx plus c. So we need to identify a, b, and c. A is what? A is the thing times x squared, which is 1. B is the thing times x, which is 2. And c is the thing by itself, which is negative 9. And in fact, we don't need that here, right? Because the axis of symmetry is x equals negative b over 2a, right? So x equals negative, and b is 2 over 2 times 1. So this is going to be x equals negative 2 over 2. And 2 over 2 becomes 1, so that's negative 1. So then the axis of symmetry is that whole thing. If you just write negative 1 there, it's wrong, okay? My pen will blow up on your paper. That's not right. X equals negative 1. X equals negative 1. All right? So then now I also know that negative 1 is my x value for my vertex, right? It's just that number. It looks awful, negative b over 2a, comma, whatever, right? But that once you find one, you know the other. These two things are the same, but the axis of symmetry must have x equals or it is incorrect. Whether I do it, you do it, the Pope, the President, I don't care who does it, it's wrong, okay? So let's look then at another one. Not another one. Let's look at the rest of this one. I'm sorry. So how do we find this here? Well, it's k of negative 1. So then k of negative 1 is going to be negative 1 squared. Must be in parentheses. You cannot, if you do this, that's wrong. I don't care who you are, it's wrong. If your teacher does it, they're not doing it correct either. All right. Hopefully they don't do that. You may think they do, but you watch and see they probably put it in parentheses. Okay. So it's in parentheses, and then plus 2. By the way, if I do it, I'm wrong too. So, but I'm not going to do it because I'm paying attention to detail there. Negative 1 in parentheses squared plus 2 times negative 1 minus 9. So negative 1 squared is going to be 1. And then minus 2, when I multiply that together, minus 9. That's its own term, right? Go ahead and multiply that. 1 minus 2 is negative 1 minus 9. Put that together and you get what? Negative 10. And that's what this is, negative 10. So the vertex is negative 1 comma negative 10. All right? So let's look at the next one here. We have the axis of symmetry. It's going to be x equals negative b over 2a. And I need to identify a, b, and c. A is negative 3 in this case, the thing times x squared, right? B is the thing times x, which is what? Negative 12. So, and then c is the thing by itself. It's just good old 7. All right? So then x equals negative, and b is negative 12 over 2 times a is negative 3. So look, I see all this, and I know that, sometimes y'all say, okay, take the negative here and the negative here. I count my negatives. If I have an even number of negatives, my answer is positive. Odd number of negatives, right, it's negative. So here I have 3 negatives. These 2 negatives make a positive, and that thing makes it a negative, however you want to look at it. Okay, so I know that x equals some negative number, and I get 12 over 6. So x equals what? Negative 2, and that's my axis of symmetry. So can I write negative 2 there? No. If I do that, I'm wrong. I'm going to miss it. Okay, I have to put x equals because and here I didn't write out axis of symmetry, but it's the axis of symmetry. Okay, x equals negative 2. It must be x equals. If it's not there, it is incorrect. When you're talking about parabolas, quadratic functions, the axis means the axis of symmetry. Okay, it's a line. So then what do I know about the vertex? I know that negative 2 is the x value. How do I find the y value? I plug it in. I do f of negative 2, right? And f of negative 2 is going to be negative 3 times negative 2 squared minus 12 times negative 2 plus 7. So then I'm going to say negative 2 squared. This is going to be negative 3 times 4 plus 24, right? I'm going to go ahead and do this as well. It's a new term. So then plus 7. Then I'm going to do this multiplied together. It's going to give me negative 12 plus, I'm going to put that as 31. Negative 12 plus 31 is 19. So then negative 2 comma 19 is my vertex for this quadratic function. All right? So let's keep moving along here. Capital G of x, 5x squared plus 20x minus 81. So again, x equals negative b over 2a. And a, b, and c. A is 5, b is 20, and c is negative 81. So let's see what we have. X equals negative 20 over 2 times 5. So x equals negative 20 over 10. So x is negative 2, right? So x equals negative 2 is my vertex there. So 20 over 2 times a is 5 with a negative out front, right? And I didn't have any negatives in a and b to change that negative sign. So x equals negative 2, and I know my vertex, negative 2. So how do I find the remainder of my vertex? Well, here I've got to do capital G of what? Negative 2. So this is going to be 5 times negative 2 squared plus 20 times negative 2 minus 81. I'm going to square this. I'm going to get 5 times 4 minus 40 because, again, that's its own term. I'm going to go ahead and do that. Even though I know order of operations says square it and then multiply that, PEMDAS or whatever, I'm going to go ahead. That's its own term. And then minus 81. All right, and then again, multiply this and get 20, but these other two terms are already simplified. I'm going to go ahead and put them together, and that's minus 121. Then put that together, and that is negative 101. So negative 2 comma negative 101 is my vertex. Now, granted, if we had a grid going 1, 2, 3, 4, 5, we wouldn't want to graph this one down at negative 101, right? We might want to make our vertical axis negative 50 and negative 100, negative 150 or something. So we didn't have to, have 101 tick marks there on our graph. So here, let's look at capital H of x, all right? The axis of symmetry, x equals negative b over 2a. A is 1, b is negative 6, and c is 1, right? A, b, c, all right? So then x equals negative, b is negative 6 over 2 times 1. So 2 negatives is what? A positive 6 over 2. So x equals what? 3. So x equals 3. And so the vertex 3 here. How do I find the rest of this? Well, this is going to be what? Nope, it's not f. My function here is capital H, right? Capital H of 3. So this is going to be 3 squared, which here, by the way, because I'm squaring a positive number and there's nothing in front of the x squared, I don't have to put the 3 in parentheses. So, but I am here just because I'm substituting it in. So negative 6 times 3 plus 1. This is going to be 9 minus 18 plus 1. 9 minus 18 is negative 9 plus 1. And then combine those, and that gives me negative 8. Negative 8. All right. So the vertex there is negative 8. All right. So I'm sorry, the vertex is 3 comma negative 8. The y value is negative 8. So the vertex is 3 comma negative 8. All right, so let's look at these here. We have this here. Now this one's a little different. This is not the same form. So what is h and what is k? Remember, h is the opposite of this. So h is 2 and k is what? So it is 7. So h is 2 and k is 7 here. So then the axis is x equals 2, and then the vertex is 2 comma 7. It's h comma k. Right? The vertex is hk, and x equals h is the axis. All right? And then finally here, This one is going to be, h is going to be 4, and k is going to be negative 11. That's this number. And then we have x equals h, so this is x equals 4. And then this is 4, negative 11, right? This is hk for the vertex. All right? So I don't know if you heard that while ago, but Siri was trying to answer something I was asking, I guess, about the axis and the vertex. So I hope this helps out with the axis of symmetry, the vertex, and the x and y intercepts for quadratic functions.